Hello and welcome. In this video, we're going to be looking at another hard and difficult pure question. This question is from Cambridge, paper 11, pure 1, October, November 2015. This is question 11 of the paper. It's a tough one, okay, for pure 1. It is tough. So let's see how we can tackle this together. First, let's start by reading the question. The question says the diagram shows a part of a curve y equals 1 plus 4x all to the power of half and a point P, 6 and 5 lying on the curve. The line PQ intersects the x-axis at Q, 8 and 0. Okay, first part tells me show that the line PQ is normal to the curve. Okay. Now, how do I show this? First, I need to understand what does the word normal mean. The word normal means perpendicular. Perpendicular means that the two things are having a 90 degrees with each other, like your floor and the wall. Okay? So over here, I'm supposed to show that the line PQ, that this line, is having a 90 degree angle with the curve. Whenever we talk about curves at points, we don't really take the curve into consideration. However, we always talk about the tangent to the curve at the point we're interested in. So, the point we're interested in is point P because this is the point of intersection between the line and the curve. So, if we draw a tangent to the curve at point P, okay, that's how we should think about it, is that we're trying to find or show that this tangent line is perpendicular to this line PQ. Alright, so this is my objective. How do I show that they're perpendicular? First of all, I need to understand that when I have two straight lines, okay, each straight line has its own slope. Okay, so let's say the first straight line has a slope m1, the second straight line has a slope of m2. m1 and m2 are perpendicular, or the line 1 and line 2 are perpendicular if their slopes are negative reciprocal of each other. What does that mean? That means if I found that m1 is equal to negative 1 over m2. That means that if I found that the slope value of my first line is equal to negative 1 over the slope value of my second line, that means that the two lines are perpendicular. Yani, for example, if line m1, let's say the first line has an equation that goes y equals 2x plus 1, and the second line has an equation that goes y equals negative 1 over 2x plus 6, for example. So m, we know that y equals mx plus c. So this value, the coefficient of x, is going to be the m. So clearly I can see that for line 1, my m here, which is m1, is going to equal 2. For line 2, my slope, or m, is going to be negative 1 over 2. And I can clearly see that they are negative reciprocals of each other. Okay? That means that this line and this line are perpendicular. Okay? So our main objective is to find the values of the slopes of these two lines. So let's call this line 1. Okay, and let's call this line 2. And we need to show that their slopes are negative reciprocal to each other. So let's start by doing that. First of all, the easier slope to find is always PQ. It's already there. Okay, so let's start with line PQ. So the line PQ will have a slope of, so let's call it m of line 2. The slope formula goes like this. You need 2 points and you do y2 minus y1 over x2 minus x1. So over here, m2 is going to equal to, let's say that this is 0.2, this is 0.1. The y of 0.2 is basically 0, minus the y of 0.1 is basically 5, over the x of 0.2 is 8, minus the x of 0.1, which is 6. So that is going to give me an answer of negative 5 over 2. So this is my slope for line M2. For line 2, so M2 is my slope. So if another line is perpendicular to line PQ, it should have an M of negative reciprocal of this value. So reciprocal means I flip it, and negative means I multiply it by -1. So if I flip negative 5 over 2, it becomes negative 2 over 5 multiplied by -1. So if another line has a slope of 2 over 5, that means that they are perpendicular. So I'm supposed to show that line 1 should have a slope of 2 over 5. So let's try and do that. Okay. So for line 1, what we can do, how do you find the slope of a tangent to the curve? Exactly, differentiation. So we need to find dy by dx of this curve over here, where y equals, let's do square root of 1 plus 4x. Okay? So let's differentiate. So dy by dx is going to equal, this is similar to 1 plus 4x all to the power of half. So what I'm going to do is I'm going to multiply this half over here and then reduce the power by 1. So it's going to be 1 over 2 times 1 plus 4x, and then reduce the power by 1. And then I'm going to multiply by the differentiation of what is inside. So what is inside differentiation of 1 is 0, differentiation of 4x is basically 4, and this is called the chain rule to differentiate. And by the way, if you need help with this, I have a tutorial on chain rule. I'm going to leave the link of it in the top right hand corner. Please feel free to go and check it out. So now that we found the gradient, let's simplify a little bit. So 4 times half, that's going to be basically 2, and then times, or I can just, since this is to the power of minus half, I can just put it down and just say that it's going to be 1 plus 4x to the power of half, or basically just square root of 1 plus 4x. Okay, so this is dy by dx. dy by dx, in other words, is the function of the gradient. So if I want to find the gradient or the slope of any tangent at any point, I just substitute the x of that point, the x of the point I'm interested in, and in this case it's point P, so we're interested in x equals 6. I'm just gonna replace it or displace it here in dy by dx, and the answer is going to give me the slope at that point. So let's put in the point that we're interested in. So let's put in x equals 6 inside my dy by dx. So it's gonna be 2 over square root of 1 plus 4 times 6. So it's equal to 2 over square root of 1 plus 4 times 6 is 24. And then it's equal to 2 over square root of 25, which is basically 2 over 5. So now what I got is the slope of line 1, so M1, is equal to 2 over 5. M of the second line, I got it earlier using y2 minus y1 over x2 minus x1. It was negative 5 over 2, negative 5 over 2. I can see that they're negative reciprocal, hence perpendicular to each other. That is basically how you show that these two lines are perpendicular. Okay. All right. Let's erase and then go into the second part. I think we don't need this anymore. So this is the first part solved. The second part, which is actually a 7 marker, it's stuff. Okay, we need to think about it a little bit. Second part says, find, showing all necessary working, the exact volume of revolution obtained when the shaded region is rotated 360 degrees about the x-axis. Okay, and then it says, you may find it helpful to apply the fact that volume of a cone with a radius r, vertical height h is given by this. Okay, so first of all, volume of a revolution means that I'm going to take my my curve and my whole region, this whole region, I'm gonna rotate it 360 degrees about the x-axis. So if I reflect it and then do this, this is basically me rotating this shape over the x-axis. Okay, so I'm gonna have a 3D shape. You should try to visualize it. 3D shape that looks something like this. Okay, so this is going to be my 3D shape, and this shape I need to find its volume. So I have a full tutorial on how to find the volume using the disk and washer method. I'm gonna leave a link to it in the top right hand corner. But basically, to do that, you need to divide your shape into small regions and think about these regions rotated. And when every region is rotated, it's going to give you a shape that looks like a disk, something like this. And then we find the volume of this disk, and using integration, add up all the disks together, and that's going to give us the volume. So to do that, okay, there's this formula that says to find, we need to integrate, and we know that the volume of a disk is basically going to be, if this is the part I'm looking at, this is the midline, this over here, this length is going to be the radius, okay, and this length over here is dx. So the volume is going to be basically the volume of a disk. This disk is similar to a cylinder, is going to be pi r squared times dx. Okay, so that is going to be the volume, and when I integrate it through the whole x length, I'm gonna find the addition of all the small disks, and that's gonna give me the volume of everything, the whole shape. Okay, however, here my shape is not constant. I have a combination of two shapes. So what I'm gonna do is I'm gonna split it into two parts. Okay, the first part is from x0 up to 6. This is the first part, and the second part is from 6 to 8. Okay, so the 6 to 8 part is easy, because when you rotate a shape that is like this, when you rotate a straight line, okay, about the x-axis, it's gonna give you a cone basically, because it looks something like this. It looks something like this when I rotate it. So I can use the formula of the cone with base radius and height, okay, to find the volume. So the radius is basically going to be this height over here, okay, and the length is, or the height is going to be this length over here. So we'll get to that. Let's just find the volume of the curve, the rotated or revoluted curve first. So to do that, let's do the integration of, we said is integration of pi times r squared times dx. Like, what is my r squared? Okay, think about it. The radius over here is basically this height, right? This value. The radius over here is this value. This is the first radius. This is the second radius. The radius here is that value. So basically, my radius is my y value, right? The radius is my y value. So I will take my y function as my radius. So my radius is going to be 1 plus 4x to the power of half, right? So this is going to equal to integration pi into 1 plus 4x to the power of half. Okay, that is my radius, and I have everything squared and then into dx, right? Okay, and now this should be always a definite integral. So as I said, I'm going to take the first part from 0 to 6. So my integral values, my integral bounds are going to be from 0 to 6. Now, let's try to find this. So this is going to equal, I'm going to take pi outside, integration from 0 to 6 of, when I distribute this power 2 inside, it's going to be 2 times half, so it's going to be to the power of 1. So basically 1 plus 4x, and then dx. The integration of that is basically, integration of 1 is x, plus integration of 4x is going to basically be 4x squared over 2. So it's going to be 2x squared. because you basically add 1 to the power and then divide by the new power. So 4 and 2 will cancel to become 2. It's just 2x squared from 0 to 6. Now I can substitute in my values. I always substitute the upper bound first and then subtract when I substitute the lower bound. So this is going to be pi into 6 plus, instead of x now I put the upper bound, which is 6 plus 2 into 6 squared, and then minus, when I substitute 0, that's just going to basically be 0 plus 2 times 0, so just a big 0. Then that is going to give me my answer. So this pi into 6 squared is 36. 36 times 2 is 72. 72 plus 6 is basically 78. So my answer is going to be 78 pi. That's the volume for the first part of my region, which is this shape over here. For the second shape, okay, we need to get its volume and then add these two volumes together to solve the whole question. So as I said, this second shape, since this is a straight line, it's not a curve, when I revolute it or rotate it around the x, when I revolve it around the x-axis, it's going to look something like this. It's going to become a cone, okay, where the radius of the base of the cone is basically going to be this height over here, which I can see it's from here all the way up to here, so it's basically 5. So my radius is equal 5, and my base length is basically from here to here. I know that this point is 8, this is 6, so this length over here is basically 2, so this is 2. Now I can use that h is 2 and r is 5, and I can use this hint that it gave me. That's why I gave you this hint, to find the volume of the cone. V equals 1 over 3 pi into r is basically 5 squared and h is basically 2. 5 squared is 25. 25 times 2 is 50. 50. So this is going to equal 50 over 3 pi. Okay? So now my final volume is going to be these two volumes added together. 78 pi plus 50 over 3 pi. And that is going to give you a final answer of 284 over 3 pi. Right. Another thing to take note of, let's say you didn't clock or you didn't recognize that revolving a straight line would give you a cone, and you didn't even take or notice this hint. What can you do? You can solve it the exact same way we solved the first revolution over here, right? Because basically it's also integration. And what you can do is you can say that I'm going to do the same thing. Volume, basically I'm integrating a piece of the disk that's going to occur, right? So this over here is going to be a small disk, okay, with this being the radius. This over here is going to be the second disk, with this being the radius, and so on. So if we take this part outside and zoom into it, it's going to look something like this, where this length over here is basically as just a small definitesimal size of x, so we call it dx, and this length over here is r, and again r is going to basically equal the y value, because r is also the y value. So I will need to find the y function of the straight line, which is super easy. I already know that it's that the m is negative 5 over 2. I know that y equals mx plus c. So y equals negative 5 over 2x plus c. I can substitute any point. Let's substitute 8 and 0 into here. So y is 0 equals negative 5 over 2 times x is 8 plus c. So 8 divided 2, that's 4. 4 times negative 5 is negative 20. So 0 equals negative 20 plus c. That makes c equals 20. Now my y is equal to negative 5 over 2x plus 20. So this is my y over here, which is going to be the radius, which is negative, how much? 5 over 2x plus 20. Negative 5 over 2x plus 20. That is my y. And it's going to be my r. So we know that the integration is going to be from 6 to 8, because I'm taking this region, okay, of pi times r squared. What is r? R is basically my y, which is negative 5 over 2x plus 20 all squared, and then multiply its pi r squared times dx. Okay, and then I can integrate this. Okay, you can either substitute or expand this binomial and then integrate each term one by one, or you can take this whole term as a bulk. I will just show you the first part. It's going to be negative integration of 6 to 8. Let's take pi outside. I'm going to increase this whole power by 1 and divide by the new power. So negative 5 over 2 x plus 20 all to the power of 3 over 3. And then I'm going to divide by the differentiation of what is inside. So differentiation of negative 5 over 2x is basically negative 5 over 2. So when I divide this whole thing by negative 5 over 2, is going to jump in the denominator. And then differentiation of 20 is 0. So that's it. This is after I integrated. Yeah, so it looks something like this. Let me... Yeah, so basically what you do now is you just... So this is 6 to 8. You substitute one time 8 into the x, and then you will get a value, and then subtract when you substitute 6, and then don't forget your pi. You should end up with the same volume, which was 50 over 3 pi. You add it to the first region and you are done. If you want, you can check this on your calculator and try and figure it out yourself. Anyways, I hope this video was helpful. Please subscribe and like, because lots and lots of questions and revisions are going to be uploaded this period because of the tests. I'm gonna do full revisions on a certain topic in Pure. So if you have any suggestions, keep it in the comments down below. I appreciate your time. Hope this was helpful. Thank you and have a nice day.